Hello, everybody. Welcome to the Bradford seminar. It gives me great pleasure to introduce our speaker today, Professor Wolfram Schlenker. Wolfram is a professor at Columbia's School of International Public Affairs and also at the Earth Institute. He received degrees from the University of Karlsruhe in Germany and Duke before getting a PhD in agriculture and natural resource economics from Berkeley. He co-directs the Center on Environmental Economics and Policy and co-directs the Energy Environment Concentration at C-PREE. In no small part due to Wolfram's mentorship, the Earth Institute's PhD program in sustainable development has produced some of the finest PhD graduates in environmental studies anywhere in recent years, including former STEP postdoctoral fellows Sol Shung, Kyle Meng, Stephanie Lochner, and our own current fellow, Alice Young. Is Alice here somewhere?
She's
the program's graduates, and Wolfram starting before them, have been key leaders in the remarkable revolution over the past decade, bringing econometric methods to the assessment of climate damages. Wolfram's research was originally focused on the relationship of agricultural productivity to climate variability and change. That is the research in this, and once he came into my scope, across my screen. You probably, did you do other things before that, or was that the beginning? That was beginning. 3 of his co-authored papers, which I recommend to all of you to read: Climate Trends and Global Crop Production since 1980, Nonlinear Temperature Effects Indicate Severe Damages to U.S. Crop Yields Under Climate Change, and Robust Negative Impacts of Climate Change on African. Phenomenal reading in the field, and taken together have over 5,000 Google citations. But he also has branched out to other climate impacts arenas, including the potential damages of geoengineering to agriculture and the influence of climate change on migration and refugee flows. I've been lucky enough to collaborate with Wolfram on the latter, a collaboration which we both love so much that we've been working on one paper since 2011. They think it's funny.
Yeah, you don't think it's funny anymore.
I couldn't help it, I'm sorry. It's the complexity of the subject, lack of effort to collaborate, which has always been fun. Wolfram's topic today is, does being a top 10 worst polluter affect environmental releases? Evidence from the U.S. Toxic Release Inventory. Please join me in welcoming Wolfram Schlenker.
Thanks, Michael. Thanks for the kind introduction. Thanks for having me here, despite having worked 8 years on the same project. So this is a bit different than the climate studies that Michael mentioned. It's joint work with Jason Scores, I should mention. And the idea behind this paper is sort of to look at this, at a modern naming and shaming works in environmental, to enforce environmental, it's not really regulation, but to enforce firms to do the right thing. We hear a lot about green consumerism and this new initiatives. Sometimes these days, where you can bring it back a little bit to the climate realm, where we have like the US getting out of the Paris Agreement and several firms or cities saying, no, we want to stay in. And so this is a particular case, one particular program, Scorecard, which at that time actually belonged to the Environmental Defense Fund, labeled the 10 top polluting facilities in each state. And what we're trying to examine in this project is whether it actually had an effect on firm behavior, whether this negative shaming has. So this is basically to give you the motivation here. So in the econ literature, there have been some examples where labeling can lead to actually beneficial outcomes. There's a famous paper that looked at health scores in Los Angeles. And not only do people stop going to restaurants that don't have a good health score, they also found that afterwards, like sicknesses went down. So it seems like restaurant might have improved what they did. So there was actually a beneficial outcome of this. So it could be that just by labeling, we can actually achieve positive outcomes from a societal perspective. So here we don't focus on the labeling of health. We focus again on like the emissions that are reported in the toxic release inventory. And so we want to know how firms could respond. So there is this community right to know acts in different forms. US was one of the first to get it. And the idea is very similar to financial disclosure laws that we have already in the stock market, where you don't actually get told what exactly to do, but you're basically forced to let all your stakeholders know what you're doing. So while there are still other laws which limit how much you can emit of certain substances, the Community Right to Know Act actually just tells you that for 370 chemicals, every year you have to publish how much you're emitting into the air, injecting into the grounds, and so forth. And the idea is just by revealing this information, you might put some pressure on those companies to sort of change their behavior. So the specific question in here is whether those publication of the data and the aggregation that happened at the time actually led firms to change their behavior subsequently when they were labeled a bad behavior. They're labeled for their bad behavior. So again, the most famous one here is basically the Emergency Planning and Community Right to Know Act in '86. It happened after the Union Carbide accident in Bhopal, where the estimates vary, but there's several thousand people died because at night there was like a gas leakage and it sort of killed people. As a response, there was sort of this heightened interest, what's actually being emitted in my neighborhood by firms. And so in this act, they basically forced, with very low thresholds, you have to have at least, you're exempt if you're less than 10 employees, if you emit less than 10,000 pounds combined. But once you reach those very low thresholds, you're forced to just basically disclose how much you're emitting for 377 chemicals to EPA. And I'm going to come back to this. This release mechanism is actually something that helps us a little bit empirically, because you report the data to EPA, and then EPA collects them all and jointly releases them. So supposedly there's this nice event study that you basically always get released sort of in the late spring to the public sector. So this kind of law has then been now pushed in other countries. On the one hand, it's kind of cheap because it's all done by the firms themselves. They report the data. The amount that you have to do as a government is sort of limited. It also sort of believes in this free forces and like just revealing what you're doing can be sort of a first step. The World Bank has been basically pushing it quite a bit. And so developing countries might sometimes do it. It sort of gets around the whole enforcement in a way that, firms have just to report what they're doing, but you don't necessarily have to monitor it. Obviously, though, you might say without the other laws that actually are on the book, this reporting might not be as efficient, because part of the reason why this reporting might be bad because it sort of signals to stakeholders that something's not going well with your company. So some groups have liked to see this expanded, and it has expanded. That's what we're using in this paper in '98. And so the question that you might ask, well, why would actually firms care about this? I guess there's a couple of sort of reasons why this might be important. When you get identified as a top polluter, you might lose sort of the potential goodwill of your customers. You might then also have restrictions on expanding your facility, which are sometimes tight. And you might just get a lot of bad media coverage. So the media coverage that we're looking at and the exact data we're looking in this paper comes from two sources. The first one, again, is the scorecard, which at the time, and it wasn't. Nowadays, you can download the TRA data from the internet very easily. At that time, that wasn't available when the '98 when we look at. So at that time, basically, scorecard collected all the data and then published the top 10 polluters of the emissions data that was available at the time. It's, again, at the facility level in each state. It was later sold and then sort of is now no longer maintained. So one thing you're going to see is that basically this data ends in the early 2000s, while what we have nowadays is the TRI net data, where you can just download all the TRI emissions from a web server. It goes much later because there's nothing. Also, the data has been partially revised. So the TRI data and the scorecard data don't necessarily completely agree on the earlier years. But in a sense, since the media coverage picked up on the scorecard data, we really want to see what scorecard at the time published, because that's supposedly what the action should then be based on. But these are the two data sets I repeatedly come back to. In a way, they measure the same emissions from the TRI data repository. Scorecard just refers to this particular ranking that EDF group did in the years that we care in the 90s. And TRI is like the nowadays revised data of the same years. So one thing why you might want to look at the top 10 is sort of very clearly shown in this graph. It basically shows you the combined emissions of the facilities in each state as a fraction of the total. And so you see the first bar is basically the 10 biggest polluters, and they basically make about 55%. Again, scorecard and TRI net are sort of similar data sets. They don't agree exactly, but you see they're very closely related. And you see this huge drop-off after the top 10. So it's basically, you have a couple of facilities which are responsible for a large chunk of the overall emissions. So going specifically after them might just give you a big bang for the buck. That's why I guess intuitively we're going after those top 10s. And I mentioned this already. Going after them, might then make it harder for them to expand. So one big challenge in the literature, though, is all those rankings and emissions obviously are highly endogenous. So you can't just run a regression of one on the other, since firms might strategically choose how much they emit, sort of thinking already whether they get shamed or not. So it's sort of a hard literature sort of to get any identification. So the one particular thing we're using here statistically is that in 1998, the program was expanded. Initially, it was only manufacturing plants, and then they expanded their sectors. And so when the sectors, basically the program got expanded, you suddenly have new facilities entering, and we use those as basically an instrument where we then say, if a lot of highly polluting plants in your particular state enter, then you get kicked off, not because you did anything good, just because these newly covered facilities come in. And so we basically, intuitively, what we're doing is we're comparing firms that get kicked out of the top 10 because new firms entered due to this expansion of the regulation to firms who then didn't get kicked off. We want to see what happens to their subsequent emissions over time. That's the idea behind this paper. So here you see the scorecard data. So there's a bit of a difference between on-site and total releases. Different. If you nowadays go to TRI, the default is total releases, which is on-site and off-site. Scorecard at the time only looked at total on-site releases. So on-site is literally that you just did it in your facility. Off-site is when you ship it to another one, potentially for waste treatment. I'll show you this a little bit later. Or to any other ones. Some do it for energy recovery. You can basically transfer it off-site for many reasons. So one thing you immediately realize is sort of the success that the TRI had in sort of lowering overall emissions. So from its inception in 1988 to 1998, so in those 10 years, you basically cut the emissions by more than half. Some firms even did much better. And then the reason why our thing works is that you then suddenly have those newly covered facilities in 1998, which is shown by the second line. And you see how their initial emissions are much larger than what the currently already regulated facilities had. And then the combined one is just the sum of the two. And again, it ends here in 2001 because scorecard, it's just the data that we got historically that they used to publish it. Now this is TRI's nowadays TRI net sort of reconstruction. Again, it's a bit different. It's on plus offsites. It sort of varies a bit also. Oddly enough, even though it's on plus offsite, you see that the new facility is actually a little bit lower in the TRI net, so there's some discrepancies. There's some data cleaning that sometimes people initially sort of had some wrong data in there. Overall, the pattern is the same, though. They've been coming down a lot in the first decade. You have a big jump of new entrants, which then basically pushes people in and out of the top 10. So that's basically what we're using here. It's a very simple instrumental variable regression. I'm not going to dwell too much on the empirics here, but we're comparing those firms who get kicked out because somebody new enters, which we think people couldn't really estimate how many people were entering the top 10 or not, and then comparing them to others that didn't drop out. So this is just restating those reasons why firms might care. There's a bit of, there's a lot of political pressure. The consumers might care. There might be potential liability. We also have circular. We have, if you ever emitted something, you might then later be held jointly liable for it. And it might also just be very hard to get a permit to expand for the company. So there's this famous quote by the head of Monsanto, which at the time was actually still a chemical company. Nowadays it's sold off its chemical stuff, and it's just bio. They're still in the news for bad stuff with the glyphosate. But the person basically vowed to cut emissions by 90%. And if you look it up in the data, they did. So the emissions that are reported are cut by 90% for Monsanto. Now, one thing that immediately comes there to mind, though, is, and I'll come back to that a little bit later, is whether those emissions are actually real or whether it's just on the books. So that's something we're going to look at in a little bit more detail in a second. And by the way, economists never have a room that's that quiet for that long. So if you want to interrupt me with questions, feel free to do so. I get nervous if nobody interrupts me. All right. So it's very simple. You get all the facility releases. It's on the facility level, so a firm can have several facilities. We then just sum them up over all chemicals. That's the default what Scorecard did. In a subsequent sensitivity check, nowadays they also give you a ranking for toxicity, so we can weight them by toxicity, but the default at the time when the top 10 were calculated is literally just the total sum of the pounds. That obviously is a little bit suboptimal in the sense that some substances are much more harmful than others, but again, I'll show later also the hazard-weighted ones. We just do this because that was the initial ranking that it was based on. And I'm repeating myself, Scorecard and TRI-net. This is just a map of the polluters. If you look at the scale on the right axis, the one thing to note here is how it's a highly nonlinear scale that we have here. It's just there's a few that are basically red. So again, this sort of highlights what we've seen earlier is that there are huge discrepancies between emissions of facilities. And you also see that there are certain states which have sort of clusters. New Jersey actually has one of the highest number of Superfund sites and TRI sites. Stop talking right now. Exactly. And then somewhere sort of out west, mountainous regions, there might be fewer. So I showed you already this data set over time. So we can break that into different subcategories. So first one is just looking at on-site releases. So again, from Scorecard, all we did was getting the total, which is the added on-site. But using the TRI-net, that's nowadays the reconstruction from then, we can sort of further decompose it. So you have on-site, and then you also have, this is important, this off-site, which is transfer for waste management. So the first thing you see is that there hasn't been much of a, one thing you might always be afraid of, and this might actually be here, something you might be afraid of in the initial is that some of the reduction of on-site comes by you just shipping it somewhere else, so it doesn't appear on your books anymore. I'll show you later results where we look at this medium, and it doesn't seem like it's just that you shift things off-site for further waste management. It's sort of very smooth around this. So the on-site releases, you can further basically segregate into, you can either release this into the air, you can lose this into surface water, which is sort of a smaller fraction. You can do it into the land, which is especially true for a lot of the new entrants, which a lot of them is mining and others. And then there's also underground injection. So on-site is just basically the sum across chemicals and across the different media that are basically being regulated. So, and the other thing to sort of look at, one thing that's sort of nice for us is the timing of this. Because you might be really worried, like we were, that this is just reduction on the books. So the firms say like, oh yeah, we're emitting less, but is this really real? Or do they just cheat in what they hand in? So one thing that's really unique here is the timing of this. So basically what happens is that you all submit this data to EPA, EP collects it all, and then jointly releases it to the world. And as it turns out, actually, this is in the middle of a calendar year. And so our argument then is basically that, so if you have year T for which the emissions are being recorded, you then basically in late spring, after T+1, you submit this to EPA. In sort of the late spring, sort of almost middle of the year, T+2, the data is being released. If you just do things on the book, you could easily adjust it in T+2. You realize, oh my God, I'm like no longer in the top 10. I can do something different because it's still half a year before you have to report your new emissions. On the other hand, changing your production process significantly with only half a year left in the year seems less like it's a thing you can actually achieve. So intuitively, what we, this sort of a test for what we're doing is we wouldn't expect anything in T+1 because you haven't even found out yet what happened about your rankings. You might see a partial effect in T+2, but it might be very hard to sort of do this given that you have only limited months available to really change your production process. And most of it you would really expect to show up in T+3, meaning 3 years later. In a way, this also sort of for us is sort of the strongest test whether this is just on the books or whether it's real. If it all shows up in T+2, we would be kind of worried. With half a year and not much time to adjust, we wouldn't really expect it. If it only shows up in T+3, we think it's more credible that they really changed something. So that's basically then for the first full year. And so the media does pay attention to when Scorecard publishes this. This is basically Factiva. It just looks at the counts of people reporting about the toxic release inventory. The red dashed line is the historic time series we got from when EPA actually released the data. And what you see in blue is basically the counts. And you see that always periodically around the time that the data gets released, the media picks it up. So that's the whole idea why shaming might work. I mean, the numbers aren't humongous. It's not like a large coverage, but you can sort of find that the toxic release inventory is in the news. And that's, I think, should be sort of, for firms, this disincentive to actually want to be in the top 10, given that you know every year when the stuff gets released, there's going to be coverage about it. OK. So the self-reporting I mentioned with the timing, we are not the first to look at this. There is some sort of debate about it. The fines that are being levied on TRMS reporting are much lower than what you get under the Clean Air Act, just to be open about it. So I think in that sense, firm might have a much higher incentive to misreport. There's also some previous work by Hamilton, who's worked a lot on the TRI, looking at taxes. And what they find there is that there's a few substances which seems to be systematically underreported. They're highly carcinogenic. It's about 15%, but then again, it doesn't seem to be for a large number of chemicals. And they are just focusing in this particular ranking on total emissions. The paper at the time, so this is not our work, basically says it's mostly likely due to the fact that they're using fairly old calibration techniques than deliberate cheating. Because, you know, with 377 chemicals, emitting them in all the different media, air, water, it might actually be, it might be hard to measure them all, and so they do a lot of rule of thumb. Another thing they did is Benford's law. You might have heard about this. So people use this for all kinds of enumeration these days. It's basically if you give people a random number, you shouldn't see as many 1s, 2s, 3s, 4s in the first digit. It should basically be more 1s than 2s than 3s. So intuitively, if you give me a random number between 0 and 200, more than half start with a 1, right? And then if you say it can be uniformly anything between 0 and I said something bad about New Jersey and they're calling in the troops. That's what happens. So there should be more 1s, 2s. So they tested this. In this particular case, for most chemicals, they couldn't reject that it's like accurately reported. There were two examples, like lead and nitric acid, I believe, that had a small like irregularity, meaning two uniform across digit. But again, given that there's 377 chemicals, there's not a lot of overwhelming evidence that there was a big misreporting. So it's a bit of a mixed bag. On the one hand, regulation only is super tight to enforce accurate reporting. There seems to be historically a little bit of misreporting, and that's why we're also focusing on this time series. So to walk you a little bit through the model, I know not everybody here, I'll be brief on this, but if you, we're doing this I do this one very simple, where I do 1 year at a time. You can also estimate them jointly. We can talk about this later, but in this particular case, what is basically, you have these emissions for facility I, you look at them in a particular period. So tau, again, remember tau is this time difference. It's either the year of the emission, when nobody knows really the new stuff yet, 1 year after, 2 or 3 years, or even more years after. That's the emissions that we're looking at. We're looking at log emissions. We want to basically get percent impact, so not total one, given the large discrepancies in baselines. So one thing to be specific, we always have facilities fixed effects because we're comparing a facility to itself. And then the other thing that's important is that we have facility-specific time trends. And the main reason for that is if you don't put them in, the standard errors get very large because you just have individual facilities like ramping down, going down in production or ramping it up. So there's a lot of overall trends. So we're measuring things, just to be clear, relative to the overall trend of a facility, which we get basically from the pre-period. And then it's basically here is always a time, sometimes mostly we put in time-fixed effects. They basically have never an effect here. Then we have this indicator variable, which is basically saying that you're dropping out of the top 10. If you're no longer in the top 10, you basically have less scrutiny by the media. So we would expect this delta here, the coefficient in front of it, to be positive. The idea is that you don't face the scrutiny anymore. You're slacking off relative to being shamed. And then there's also a ranking fixed effect, because if you rank number 10, you're much more likely to be kicked out than if you rank number 1, meaning the top polluter. So you want to adjust for that. In the sensitivity check, we also interact this instrument by rank. It doesn't really change much. The coefficient goes down a little bit. And then the first stage here is basically the same controls as we had before, but we're instrumenting whether you're getting kicked out by how many new top 10 facilities enter in your state. So that's basically the idea. And so same other controls. So the N, the new, is basically what we're using here as the variation. And the variation is plotted here. So it shows you like the number of newly regulated facilities that make it to the top 10. Nice for us is it doesn't look like it's highly clustered. Like if it would be all the Midwest, we would be kind of worried that we're like picking up trends that are different in the Midwest than somewhere else. But we get some fairly nice variation across the US. It's not like graphically all clustered who has like the big new entrants. So that sort of is good for our statistical. So the first thing we do is to just check whether this top 10 expansion is correlated with some other thing that we might sort of spuriously pick up. So if you just look at the population data, which is like, you get the coefficient, which is basically here is a regression of linking this particular characteristic of a state to how many new top 10 facilities they get. And there's no significant correlation for any of the socioeconomic controls here, whether it's the fraction that is white, black, the per capita income, or other things. So nothing is significant. There are some in terms of the what firms are there. So if you have higher number of manufacturing firms, then you have a lower probability of having a lot of them, which is not really that surprising because the manufacturing firms are the ones that are originally regulated. So if you have a lot of them, it's less likely that the new firms kick you out of the top 10. So that's sort of a bit different here, one of them as a control. All right, let me then go into the results. So this is just highlighting those results net of the facility fixed effects. So what you basically see here is intuitively all we're doing is breaking the data set of those top 10 polluters into two groups. The red one is basically the one that drops out of the top 10, and the black one is the one that stays in the top 10. And so you see how they have roughly similar pre-trends. Then this is the year when the emissions 98 where the expansion happened. The first year after where nobody knows anything yet about the emissions of the new entrants, and there's really no effect at all. Then you see T+2 where you have half a year to change something, get a slight widening. And then what you said earlier, the big widening basically happens in T+3. So that's basically the big effect. And again, it's not that you basically really increasing your emissions. The positive thing is just relative to the one that continue to be shamed. So basically, you're reducing it less than the other one. So it's a positive, but it doesn't necessarily mean that you're going up in absolute levels. This is all like relative to the other group. And then if you use the TRI net data instead of the scorecard data, which extends further, you basically see this widening here. So if you want to do this as a regression framework, so again, this is now data from scorecard in the top panel. This is just the coefficient of this gap, which you basically is here. But it's like a formal regression model. So what you see here in the first 4 columns, A through D, it basically is the US states, so the 50 states. And then what you see in the later one is that it also includes the territories like Puerto Rico and others. And so what you see here is, there's no effect, nothing significant, which is usually shown with stars if it's significant. In 1, if tau is 1, meaning the year after, tau equal to 2, there's nothing significant. And then again, tau equal 3, which is the basically for 1998 data. 2000 EPA releases them in the middle. And 2001, we basically see that there's suddenly a big widening between the ones that get kicked out and the ones who stay there. And then actually, if you include the territories, sort of similar thing, except that it's a bit smaller. It might be a bit smaller if you think that the political pressure there might not be as strong. Then if you use TRI net data, which is basically redoing the same thing here from scorecard, you again get similar things, except that there's one small, marginally significant for the first period. But it still holds at the highly significant 1% in period 3. Again, the 0.53 doesn't necessarily mean that you just have higher absolute emissions. If you look at the distribution of the trends in emissions, about 0.16 log points per year, so over 3 years, it's 0.48, so it basically just offsets your trend that you would have otherwise had. Okay, so having shown those sensitivity checks, I have like 15 more minutes. I show you a couple of sensitivity checks. The first one we can do is, so the TRI net data that's nowadays, like basically the clean version of the 1990s, that's something that at the time wasn't available to firms. So we can sort of differentiate a bit whether we do the ranking based on what was available at the time, whether it's the ranking based on what's available now. And what you would imagine is that firms mostly respond to what was available at the time. So that's what we're doing in those things here. We're basically looking at facilities, a ranking They can either be ranked based on scorecard or not. And then we look at emissions. They can either be ranked based on TRI net or scorecard. So, and remember, scorecard was the estimate at the time. TRI net is the clean one from today. And the interesting thing we find here is that, if you look at just the scorecard data, whether you look at the release estimate from scorecard, TRI net, it doesn't really matter a big difference. Whether you just use on-site or total, it basically always gives you this 0.5 decline. Another thing I sort of just skimmed over without really telling you in detail is that in '98, when they expanded the program, they didn't just expand the facilities that were being covered, they also expanded the number of chemicals. So there's new chemicals entering. So what the last two columns basically do is they just keep the set of chemicals constant to the same from before the expansion and omits all the chemicals that happen after the expansion. And again, you get similar results. So it's not driven by new chemicals, even for the old regulated firms suddenly having big jumps. This is sort of the scorecard and TRI net. And I think that the interesting thing is if you nowadays go to the TRI website and you just download the default data set, which is total releases, the interesting thing is then if you then look at here the last two columns, they're no longer significant, which basically says that if you look at those chemicals and the ranking based on those chemicals that are basically that you nowadays brand as sort of the total basic message that's being put out, the effect doesn't happen. In a way, we like that because it gives us more confidence that firms really responded to scorecard, because it means if you put in the ranking that at the time was available, you see it. If you put the nowadays reconstruction, which at the time, again, nobody knew, so it wasn't available as the total one, then you don't find it as much. So they seem to really have responded to this particular news release. So in terms of, gets technical here, but you might be worried that, I showed you earlier, there's some certain correlation with manufacturing plants. So what we do here is we basically interact not just the overall time effect, but we do it basically by a first digit, second, or three-digit standard industry classification code. So we could basically say you allow for common shock to all oil producers. You allow for even more fine scale like paper mills, depending on those. And the idea here is, again, if you look at the coefficient and how we estimate it, it basically is very robust to this. The last column, too, is a bit of a difference that we basically interact this top 10 instrument with the rank. So instead of just having like number of top 10, it's basically number of top 10 times your number 1, number of top 10 who enter, like you were initially ranked the second most polluter, and so forth. And it goes down a little bit in magnitude, but it's still highly significant. So we can control for a very wide set of like industry-specific shocks, and it doesn't really seem to change anything of what we find. The same is true for like TRI net. Again, this was scorecard. This is TRI net. Usually TRI net numbers are slightly larger, but the overall pattern is sort of very consistent between the two. So another thing you might then worry again is, do you just ship it from on-site releases to off-site, or what happens? Or one thing that could really go wrong is if you just regulate total emissions, that you basically get a lot of really benign stuff out of the air but produce more carcinogenic, which would be very bad. So we also do like a hazard-weighted ranking. So there's a nice paper by Max Alfam and Ryland Kellogg, which basically looked at ozone regulation. And what they found is that it's basically now vapor pressure that is regulated. And they found that the regulation is so linear in the sense that it doesn't really tell you how to basically achieve this reduction, that the firms pick the cheapest one, which doesn't have much of an environmental benefit. So there's sort of this cross-substitution between what they actually use. So that's then basically the hazard-weighted one. So it gets a bit irkier because you see the number of observations starts to really decrease because not every facility ejects something in the underground. So the data sets really gets limited and the standard errors really blew up. So I don't want to make too much out of it, but we see sort of air and water still this positive, and air is sort of this thing that seems to drive most of it, and the water is the surface water discharges. They're still significant. Now the land and the underground, especially even the first stage, isn't really even there. So I don't want to do it, but nothing there is sort of negative. Now importantly though for us, the wage transfers, you might be worried whether they just get rid of the problem by outsourcing the problem to another facility. That doesn't seem to be the case. there doesn't seem to be like a significant uptick by how much you just, I reduce my emissions. So there could be sort of an offsetting effect for waste transfers. But we don't find anything significant. And then the last column is basically just not adding all the chemicals based on total pounds. It basically adds them based on the toxicity of the chemical. And so the toxicity weighted one actually finds something even larger than if you just do the unweighted one. So it's suggesting that it wasn't like a substitution from benign substances to more toxic ones. Then just to drive home the point that what we're doing is not like some spurious trends or correlation. We're doing this placebo where we just pretend that everything happened a year earlier. So we basically pretend the new ones come online in 97 instead of 98, which isn't the case. So we purposely offset everything by a year. If you're worried that all we're doing is picking up some weird trends that happen, you should then still see it. But when we do this with a purposely wrongly picked year, we don't find anything significant for any of them. So that's sort of reassuring. So the results are not just driven by this facility time trends or some overall trends that happen in manufacturing states. It seems to be really tied to this 98 expansion. If you do it just 1 year earlier, you basically don't see anything. And OK, now it gets a bit more technical here even. So again, I told you we need those facility-specific time trends, because if you don't include those time trends, we basically have too much variety. Like the standard errors get big because like some facilities are expanding, some are sort of reducing. We sort of need to normalize it to something. So the question is, how many years do you include in your pre-trend? So we need to include at least 3, because we have a facility-specific fixed effect. So that takes away 1 year. You need at least 2 years if you have a fixed effect for each one of them. Now, if you have a facility-specific time trend, you need a third one to get the trend. So the minimum is 3. It's the bare minimum, and then the more you add, then basically the more you can basically identify those pre-trends. And so this is basically done here with the scorecard data. And so you see that if you use the bare minimum of the 3, then standard errors are big enough that while it's not significantly from our baseline, it's not significant by itself. But if you include it as 4, 5, or 6 years, it doesn't really make a difference. So it sort of seems to stabilize. And again, 3 is the bare minimum. But it doesn't seem to be super sensitive once you have at least 2 degrees of freedom per facility, meaning 4 years or more. All right. So let me conclude, and I'm happy to take questions. So in this paper, we were interested whether this public shaming had an effect on the emissions of firms. We are looking at this 1998 expansion, which expanded the chemicals as well as the facilities that are being covered. We do find that those companies that remain on the top 10 basically reduce their emissions by more than if you get dropped out. So it does seem to have an effect. It really impacts firms. We feel there's sort of 2 things, that this is not just on the books. The really first one that's important is the timing, that you don't see it in T+2 when sort of the data becomes available mid-year. But you only see it when they have a full year to actually look at that. We also as the second one why we think they might really care about this is that there is this media coverage uptick whenever the data gets basically published. So unintended consequences, yes, it's good to focus on the top polluters because they do basically 55% of the pollutions. On the downside, though, when you sort of take the pressure off them because they drop out, they seem to start slacking off a little bit. So it seems to be like that if you take the careful eye off them, they seem to sort of not be as diligent as they otherwise would have been. But by itself, the program seems to have had some of the intended consequences that were designed to sort of encourage firms to do the right thing by putting them subject to scrutiny. So I'm looking forward to your comments, and thanks for coming.
Do we have any understanding of the interaction of these firms with the public? I mean, if you have some firm that is somewhere way up the wholesale chain, that the public doesn't have any direct consumer influence over that firm, versus a firm that sells something that the public can buy. So it's not just a matter of pressure, political pressure, but consumer pressure. Do you know what's the mix? Because if you have a lot of emissions from a firm that most people never heard of and don't deal with and never see a product of in any direct sense, then you have to wonder a little bit about the mechanism.
Sure. I mean, I haven't looked at those kind of heterogeneity. It might get a bit iffy in the sense that we have like, 50 states times the top 10 polluters. We have like 500 observations. So we could split it down and like look at heterogeneity, whether you're like an end producer or whether you're like a mining company, which most people don't know much about it. So I haven't done that split, but it's a good suggestion. I guess oftentimes though it's even just the local residents, even if it's not a final product, who care about those things. So if you like, you saw like in Utah, there's like one particular one that is very red. So that has like huge emissions, and I think it's not necessarily just the green consumer, but I could, the short answer is I should do it. I should look for some heterogeneity, which I have not done. So it's a good point.
Questions?
I was wondering if there's any estimates available for how much money firms spend in order to get these emission drops, like whether we have any idea of what the cost effectiveness for companies of this program versus something more like the Clean Air Act where they get fined when they go over.
I see. So I'm not aware of a particular data source. I would love to hear it. So there's only there's this pollution and pace, the pollution abatement expenditure survey that comes from, you can get from the sense of manufacturing. I don't know how I would attribute it just to this program or not, but I guess you could see, I don't think it reports in 98 anymore though. Otherwise you could basically look at whether the same thing we did here, when you ease off, whether your expenditures go out. So there might be one way. I mean, we also looked at like stock prices and others, but the problem then becomes, again, these are facilities, and certain companies might have several facilities, and then going up to the stock price, we don't have the actual breakdown just for the facility level, right? So it's harder to sort of look at this directly. So I think another thing, so this goes not to the cost, but to sort of verify that they're really doing something. We're trying to currently verify it with like satellite data. It's just hard to get it back to 98 because most of the products start later, and you guys might actually know more than me on this. If anybody knows a good product from 98. So it would be nice to see, since these are supposedly the biggest polluter, we should really detect them in some satellite measures and then realize that in those facilities that supposedly dropped out and slag off, that the satellite reading as an independent reading also shows us. But I don't have anything on the cost, unfortunately.
I'm retired now, a former regulator, air pollution.
Okay.
Just 4 observations. One, New Jersey, ranking nationally, I don't think we have any facilities in the top 100 today. And that's primarily because not so much the control, some most of it shut down. New Jersey used to have a very large chemical industry in I go back to the 1970s. Today it has very few facilities. We used to have big drug making facilities. We got drug companies. They don't make drugs in New Jersey. They don't make drugs pretty much in the United States. Two, one of the advantages of this is it enabled regulation by states. New Jersey took information like this and developed their toxics regulations. And that helped regulate control, and it also drove the chemical industry down. So shutdowns, I think, are extremely important in a national trend here. And finally, small facilities are important. You find small facilities are in population areas with short stacks, short property lines, and my experience is that the small facilities in populated areas have much higher risk per person, maximum individual risk, than the large facilities.
Oh, okay, so fair enough. So what I meant by New Jersey is the number of dots, not necessarily the emission. So you're right that they're not. So I should be more specific on this.
Yeah,
so.
And if you look at the top facilities, New Jersey would have 0.
Yeah, so we do the top 10 by state, but I think your second point about the regulation by state is the reason why you do the top 10 per state. So there might be something happening by the state. So that's good. So your third point about the small facilities being more harmful is, so you have a colleague You have a colleague here, Janet Curry, who has a paper on TRI emissions and like health effects, and they don't look at the 98 expansion, they look at later ones. And they find it's mostly people within a mile, so fairly local. But I think since we have this instrument, we could, It's hard to get geocoded health data, but if you have geocoded health data, it would be nice. For the whole US, it would be nice to sort of see whether it's true, whether we actually see sort of a change in mortality rates in the places close to those big facilities. Might be worth looking in, given this other research that sort of, but it would have to be really microscope, like within you said 2 blocks or something, so it has to be really geocoded. I like that.
Is there any comparable analysis in the EU or in the OECD? Because you mentioned other countries had accepted some of these reporting mechanisms.
So I'm not aware of anything done in Europe, like looks at the similar thing. Again, the problem is that sort of to get the variation, like because firms sort of pick how much they emit. I don't know. I don't think I know of an expansion. The one thing that sort of people started using in Europe, which is nice, is that it actually includes CO2 emissions, which the US does not. So if you care about, European trading system and what effect it had on firms and whether they really changed their emissions, you can use their TRI equivalent to look at facility level emissions. The regulation in Europe is a little bit different also that it's a rotating panel, meaning not every firm is in it every year. And so sometimes you drop firms when they're no longer subject to it. But yeah, in short, I think I haven't seen, partly that's why we did this, I haven't seen any regulation, any other paper that looks at a similar regulation elsewhere.
Thanks so much. You at Princeton Environmental Institute. So just a couple of quick questions. You had a point where you were like, well, are companies misrepresenting what they're releasing? And you said, well, it's probably not deliberate cheating, it's more likely to be outdated equipment. I'm wondering if you can kind of mix those two together. So if I know that if I install this newest sensor or something, then it will tell me that I'm polluting more than if I keep using the old one. So I have a good reason working in the company to just stick with the old one. So I'm wondering if those two things come together. And the second thing is with the unintended consequences, are you ready to just come out and say that it's probably better to have a graded system, which is more granular, so you can get a A+ grade or a B- grade or E grade, and that will remove some of these unintended consequences, or is it more complicated than that?
And let me add a question which that stimulates, which is, do you know of any studies that ask the question of what goes on inside these companies in terms of decision processes around this? It's hard to get any information about that, but maybe somebody talk.
So first for you, yes. It could be that equipment changes something, but I guess since we're looking at facility-specific things, what happens over time, it would have to be that you time your equipment change to when you realize you drop out or not. And so then the story would be that the new equipment shows that you're doing less or something, right? I think that's part of the criticism of the TRI is that it's actually often not that elaborate. A lot of it is actually rule of thumb. They basically say this is how much we produced, and then this is our conversion factor, and then boom, there you have it. So since there's so many chemicals. So fair enough with the graded. I think partly it's because people want something catchy, right? Like they're just top 10, these are the big ones, and so you highlight them. If you do A+, like that's what they did for the health grades later, right? So I don't have the counterfactual. So we thought about for a while also whether we do a regression discontinuity at 10, because if you just at 10 versus at 11, the problem with that one is obviously if you're firm number 10, you have a huge incentive to change something because you want to get off the list. So the RD, when you have endogenous sorting, it's not really a good RD. So we haven't done it. So one of the things, this Hamilton paper in Texas that I cited, they actually tried to measure. They didn't measure like all 377 chemicals, but I forgot. It's like 10 or something. So they actually tried to measure. There were some emission monitors in that state that captured some of the chemicals that the TRI supposedly reported. And that was the one that found that the majority of them seems to have correlation with them. But I'm not aware of a study that systematically examines how firms report that. I think it's just sort of specified that you in the law, but I don't know enough about the groundwork, I have to say. Maybe I should talk to more TRI managers how they actually do it to get a better idea.
Yeah, so I try to generalize your talk. There's two high-level messages, one of which I kind of knew and one of which I didn't.
disclosure makes companies pay attention. And you mentioned that the companies in any field, when they get the data out, they say, my goodness, it was Monsanto, I guess.
Yeah.
So that all by itself helps. And there I want to know whether I would have thought a pushback from the firms that these numbers have competitive value would have made TRI less successful in terms of, I mean, usually a company, EPA would get all these numbers and aggregate them, and they talk about the industry as a whole, but you're saying the company's actual numbers for emissions of particular chemicals are in the public domain, and I would have thought that very hard. The second thing is that shaming works, if I understand your bottom line, which makes me ask, well, where else have we studied shaming? We've said, and Michael's question, do we know inside the companies how it works by some in-depth understanding of companies, pressure comes from stockholders, consumers, local governments, and regulators. We have a lot of texture to pull out with in-depth studies of some of these things. Is that going on? I mean, shaming works as a high-level conclusion that if it's really robust, would affect a lot of environmental policy.
So I think there's a few qualifications. I think shaming in this context works because there are other really stringent laws on the books, right? I'm not sure shaming by itself would work without the other laws, because I think by shaming that you're emitting a lot, you're signaling that you might run afoul of other regulations which are costly, or you might lose consumer goodwill. This study is not capable of telling you which of the two it is. And it might very well be as if you had, like the World Bank is pushing this in other countries. If you have no other form of liability or any other regulation on the books, even publishing the numbers might not do a lot, because it might be not consequential enough for firms to take this serious. Because it's definitely true in the US, in the US this is not TRI emissions, but if you're not in attainment for our national criteria are pollutants, then firms cannot expand as easily. So environmental regulation can be quite costly for firms. I think they're very acutely aware of that, especially the big facilities here. They're like big, chemical or manufacturing facilities or anything. I think they usually have other sort of environmental divisions. But I guess similar to Michael's point, I should know more. I don't actually know exactly. I don't know enough how the command chain that would work to actually do this. You asked earlier whether there's other examples whether shaming works. I think there are other examples. People study on there's other indices nowadays about how environmental beneficial your product is, and then people look at firm productivity. So oftentimes people have argued that firms that are socially responsible are also more profitable. Now that literature is a little bit tricky, sort of, if you think about it causally, because some other people say it's just a reverse story. If you're more profitable, you can afford to sort of be more better environmental steward. So I'm not. So there are the studies, but I think some of them suffer maybe a little bit from the statistics, whether they really. It's harder to establish which one causes which. But there's other. So to answer your question, I think there's evidence out there that people claim it has an effect more wider. I'm not so sure whether the statistics is super sound for some of the studies. But yeah, I think one thing I wanted to tell you though is there is a bit of a role for government though, because you could argue, if shaming works, why don't we just do the opposite? Why doesn't firms proactively say, hey, if shaming works, I want to distinguish myself from my competitors by proactively say I'm good. And I think often this is harder to do because consumers have a harder time assessing how good your information is. So for me, the prime example for that is basically like organic. There used to be a lot of labels, and people had a hard time assessing what it actually meant until the government came in and did like USDA organic. I think sometimes the government still has like a role just in even sort of basically signing off on the quality of the particular products that are, or the things that are being published.
Amir?
So I wonder if accounting for macroeconomic factors such as unemployment or political factors, like who had the office during these years that the data were learning what party had the office when this public shaming was happening, could actually change anything or give more information about does it really work?
I guess it gets back to the New Jersey one because it's the state regulators. So, I mean, one thing we could definitely do is we have the top 10, and we could just interacted whether you're in a Republican or a Democrat state. We don't have that many observations. We can split it in half. It would be interesting to see whether dropping out of the top 10 in a Republican state is different than in a Democratic one. So I haven't run that, but it's a good idea. So I'll next.
What do you mean by public? Is it state level?
Since most of those, the state plans, I think I would look at the governor. I mean, I don't know. Is that what do you think might be the most sensible? I would think, since this is state usually implemented in the state plans. Because the federal level, so we have year fixed effects in there, right? So the overall year thing, we couldn't do anything like the federal level is on the government because it's the same for all states. But we look at this heterogeneity among the states, how many new top 10 come in. But we could interact that with your state level government. And I think, there might be a little bit of a split, but by and large, like the governor and like the house or whatever in the particular state is usually closely aligned politically, right? So you can just do by majority red versus blue state.
On that point, it does matter whether a state can regulate locally or not, but the political parties. My experience has been it was easier with the Democrats than the Republicans, but that didn't mean that we didn't accomplish things with Republican restrictions as well as Democrats. One other point I want to make is that if you look at actual air toxics in the air today, the major facilities, at least in New Jersey, have a very minor role, perhaps 15%. And automobiles, diesel engines especially, off-road and on-road, over 7%. So today, it's not the top 10. It's not even the major stationary source in industry. It's us. It's our cars, and especially trucks.
So
Yes.
Yeah, I'm a little concerned based on the unit analysis. I was just wondering, are you worried about strategic behavior by firms? For example, if one of their facilities is on the list, could they just divert it to another facility? Or potentially, relocate production to another state or import? I mean, is this just essentially redistributing the emissions so that it's not going to show up?
So it's a valid point. So Matt Gibson has a paper on that, but he looks at TRA data, but it's not based on those top 10 releases. It's based on whether you meet the national ambient air quality standards or not. And so what he finds is if you're in a non-attainment county, it looks like companies are reallocating production to facilities. Now, there's sort of a two-answered question to that. If you believe that the threshold that EPA says for national ambient quality standards is accurate, it's really a threshold and there's zero harmful health effects below that, then this would be fine, right? Because you were basically reallocating pollution from places where you're above the threshold to where you're below. I think empirically most studies think that there's even some health benefits below the threshold. In that sense, you basically would clean up certain places at the expense of others. But that is like for ambient air quality standards. For this particular paper, we're looking at this expansion in '98. So I have a hard time imagining that the firm could correctly have predicted like how many new entrants will be in their state. That's why we're particularly looking at this episode. Because in other years, it's sort of what you say, the big challenge would be is that firms might just endogenously like change how much they do to get it off or on the list. So that's why we particularly look in this year. But your point is well taken. There might very well be reallocation. I think ambient air quality standards is much more stringent than this public releases in the terms of like the implication for companies. But there it's definitely been shown that it can be the case. And I guess I didn't really answer your Rob Solar's question on. So I think the reason why firms just had to accept this TRI data is because Bhopal. I think there was a huge public outcry. There's a study that also looks at abnormal returns of oil companies and chemical producers in the US following Bhopal, and they all had really high negative abnormal returns. I think it was just a period where there was a lot of public pressures, and it was just not feasible for firms to push back against the fact that they have to publish it.
Okay, well, we've come to the end. Can you stay a few minutes if people
Sure.
have questions?
Thanks again for having me.